In Chapter 8, Section 6, we're going to work on solving some more, but this time we're going to solve trinomials. So by the end of this lesson, you should be able to factor these trinomials with a leading coefficient of 1, and then solve these trinomials. So before we get to the actual lesson, let's see if we can talk about some numbers in two different ways. If I ask you to find two numbers that add to make 7 and multiply to make 12, there are millions of numbers that add to make 7, but there's only a few that multiply to make 12. 1 and 12 do, 2 and 6 do, and 3 and 4 do. Those are the only possibilities that multiply to make 12. And now the only ones that add to make 7 out of those bunch are 3 and 4. We're going to use those numbers for what we're going to do today. Same kind of thing for this next one, except we're multiplying to make a negative number. So remember, if you multiply to make a negative number, that means only one of them is negative. This time I want these numbers to add to 1. So because they're going to add to positive 1, you know the bigger number of the pair has to be positive. So let's go through our factors of 90. We got 1 and 90, 2 and 45. We could do 3 and 30. 4 doesn't go into it, but 5 does. 18 times. 6 goes in 15 times. 7 doesn't fit in, 8 doesn't fit in, but 9 does 10 times. And then 9 and 10, and we'd go back to where we were at. So remember, one of these has to be negative, but we want them to add up to 1. So hopefully you're thinking this 9 and 10, those are only 1 apart, and it would have to be positive 10 and negative 9 in order to get that to happen. Same kind of thing for this next one. I want to find two numbers that add to make negative 15 and multiply to make positive 50. So if they're multiplying to make a positive number, two things can happen. They're either both positive, like these guys up here, or they're both negative. And because they have to add to something negative, we know that's the case. So run through your factors of 50. 1 and 50, 2 and 25, 3 doesn't fit in, 4 doesn't fit in, 5 and 10, 6, 7, 8, 9, that's it. And if we want these to add up to negative 15, we know both of them have to be negative. It's going to be negative 5 and negative 10. So if you know your multiplication tables, these should be pretty easy and quick, and then that will really help you with what we are doing today. So we already know how to do what's on the left side of your page, but we don't know how to do what's on the right side. So let's do what's on the left side and see what we notice. I have two binomials multiplied together, so I need to double distribute. So x times x gives me x squared. X times 2 gives me 2x. Negative 10 times x gives me negative 10x. And then negative 10 times 2 gives me negative 20. And then I have some like terms here that I can combine, so I end up with x squared minus 8x minus 20. Now, this happens to be the exact same problem that I gave you over here, but this time I want you to factor it. So I want you to take it and turn it into two things multiplied together. And every single one of these that we're going to do today is going to fit a pattern. And that pattern is going to have an x at the start of these binomials, just like this, x and x. And that's because when we multiply that together, we get this x squared. And then these two numbers here, the negative 8 and the negative 20, come from the 10 and the 2 back here. And the pattern you should notice is these two numbers, negative 10 and 2, add to make the number in the middle, and they multiply to make the number on the end. So you are going to ask yourself, what two numbers add to make negative 8 and multiply to make negative 20, just like we were doing on the other page. Now, something I like to set up just to kind of organize my thoughts is this x thing here. And then I just put stuff in here. I want numbers to add to make negative 8 and multiply to make negative 20. Now this isn't necessary, this is just something I draw on the side of my paper to organize my thoughts. So you'll see this a lot when I do problems, but the two numbers that do this are going to be the -10 and the +2. And then those two numbers are going to be what goes in these parentheses here. And it doesn't matter what order you put them in, the -10 first or the +2 first, because we're multiplying. We'll eventually get the same answer. But this right here, oops, is the factored form of this guy right here. So that's what we're going to be doing. So let's see if we can do it. Factor each expression, and then we can always check our answers by double distributing and see if we end up with what we started with. So this guy here, we have g's instead of x's, which is no big deal. But when I factor, I know it's going to fit this pattern. I know it's going to have g times g here to give me this g squared. Now I somehow have to get a 7 and a 10 out of this. So you need to ask yourself, what two numbers add to make 7 and multiply to make 10? Now, the more of these you do, you'll be quicker at just coming up with these numbers, but remember, if you need to, write down all the multiples of 10. We got 1 and 10. Those don't add up to 7. We got 2 and 5, and those do. So this 2 and 5 right here are the numbers that we're going to put in our parentheses. And just like I said in the last slide, it doesn't matter which one you put first, because we'll end up with the same answer either way. And that is the factored form of what we started with. So let's try another one. This time there's v's here. So the pattern's the same. Remember, we put the two v's out front so that we end up making v squared when we start to double distribute. And then we got to ask ourselves, what two numbers add to make the number in the middle, so 21, and multiply to make the number on the end, 20. And if you need to, go through all the 20's factors. You have 1 and 20, and hey, we can stop right there because 1 plus 20 gives me 21. Oops. So we end up with v plus 1 times v plus 20. I want you guys to try C on your own. Now, these ones get a little weird because if you look, they have two variables. This is a weird case, but we're going to set it up exactly the same. If you noticed, you have an x squared in the front here and a y squared in the back. So instead of just setting this up, that'll take care of this x squared out front. We also need to take care of this y squared in the back. So we're going to put two y's back here so that when we double distribute, we get y squared. And then in the middle here, you have x times y. And that's going to happen when we do like these two multiplied together and these two multiplied together, which is good. And then we got to figure out the numbers that go here, just like before. So these steps are exactly the same. You want to find two numbers that add to make the number in the middle, which is 11. And these same two numbers have to multiply to make the number on the end, which is 24. Start going through your factors of 24. You got 1 and 24. Those don't work. 2 and 12. We're getting closer. 3 and 8. And those are going to be the ones we want. I don't know why I can't write down here. 3 and 8. So this, remember, goes with the second term here. So it looks like this. And if you ever get stuck or want to know if you're doing these correctly, remember, you can double distribute and check your answer. X times x gives me the x squared. X times 8y gives me 8xy. 3y times x gives me 3xy. And these two added up make this 11xy. And then our last one, 3y times 8y, gives me the 24y squared that's back here. So let's try this next one together. Remember, set up your pattern first. So we need two v's out front to take care of the v squared. I have the w squared on the end, so I need w's back here. And then double check that the stuff in the middle is v times w, which we'll get when we multiply, oops, here and here, which is what we want. And then you got to figure out your numbers that go in these spaces. Our two numbers have to add to make 2 and multiply to make negative 48. Now because they multiply to make a negative number, I know that one's got to be positive and one's got to be negative. So when I run through my factors of 48, I'm not just going to add them together, I'm also going to subtract and see if I can get 2. So none of these are working. And I can go to 4, 4 and 12, I can go 6 and 8. And those ones work. If I subtract 6 and 8, I get 2. Now because it's a positive 2, I want the 8 to be positive and the 6 to be negative. And then just like all the other ones we've done, it doesn't matter if you put the 6 first or the 8 first. Now, what is the point of all of this? Why do we bother doing this? Well, because we need to solve things that look like this. Now, if you look in this problem here, you have a z squared and a plain old z. So we can't do what we've done in the past and just get z by itself and say z equals like 6 or something. Because there is a z squared and a plain old z there, we can't combine them, and there's two different variables there. So what we can do instead is we can use the zero product property to solve these guys. Now remember, the zero product property says that two things have to multiply together and equal 0 before you can split them up and make each of them equal to 0. So that's what we got to do here. This very first equation I gave you doesn't equal 0. So that's always got to be step 1, is make this equal 0. So I'm just going to move the 70 over. So now it equals 0. And then we need to turn this into the product of two things. And that's what factoring is for. It takes something that is addition and subtraction and turns it into multiplication, which we can use. So set it up for what our pattern looks like. And then let's find our two numbers. I need two numbers that add to make a negative 3, and they got to multiply to make negative 70. Remember, they multiply to make a negative, which means one's got to be positive and one's got to be negative. And because they add to make a negative number, the negative one's got to be the bigger one. So let's go through. We have 1 and 70. That doesn't work. 2 and 35. Well, that doesn't work. 5 goes into 70 14 times. That doesn't work. And 10 and 7 multiply to make 70. Those are the ones we're going to use. Now, in order to make it add to negative 3, I got to have the negative 10 here. So we get this. Now that I have two things multiplied together and they equal 0, instead of just being done with this like we were with the other problems, we're going to use this zero product property, which says z minus 10 has to equal 0, or z plus 7 can equal 0. And then all I have to do is add 10 to both sides and subtract 7. So these are my two answers here. And if I were to plug these in, they would work in my equation. So that's what this check your solution means. Plug in 10 up here. We would get 10 squared, which is 100, minus 3 times 10, which is 30, which gives me 70. We can do the same thing with negative 7. Negative 7 squared is 49. Negative 7 times negative 3 gives me 21. And guess what? When you add those together, you get 70. I want you guys to factor this next guy and then type your answer in, and then we'll go from there together. So once you factored, you should have found that your two numbers were 6 and negative 3, so you have x plus 6 times x minus 3. And now because these two things are multiplied together and they equal 0, we can use the rule that says this guy has to equal 0, or this guy has to equal 0. And then it's super easy to solve because they're nice linear equations that we know how to do. And you end up with negative 6 and 3 as your two answers. And just like the last ones, you could plug them in and double check. So you have two to do on your own. Factor these guys and then solve. Make sure you write down any questions you have and we can go over them together in class. Enjoy your night.